I want to cover some other aspect in this overall approach too. One of the thing is I want to take a specific instance of the problem. So far I have been talking about capital V, capital H and so on, but let's take a very specific instance of this problem. So if I take this specific instance of the problem where I fix the height or capital S to be 5 inches and the volume to be 100 inches, okay, then I substitute this overall thing in my equation that is given here. So if I go back and if I look into this equation that was here, this equation right here, right, and if I do that, then this equation could be simply written as, the objective function of the overall equation could be written as 20 plus 200 divided by w plus 10w. It's a function of single variable. From the previous slide we can use that and we can write this equation. One of the other ways I can solve this problem is in a graphical approach. Last couple of slides we saw an analytical approach, but now we are going to see a graphical approach to solve for this class of problem. So what I can do is I can take this function, and since this is a function of one variable, I can increase, for increasing value of w, I can give a plot, I can get a plot which I will call the plot of the optimization function, and looking at the plot itself, I can decide what is the optimal solution. So let me give you that solution, and one of the ways you can do that is probably you can write a Python code, and I will show you that code in a little bit, how we arrived at this code. So I can basically take this function, I can plot this function, okay. So as the w is increasing, the nature of this function is going like this, and that's the plot that we can use. Now from this graphical approach, the graphical plot of this function for a specific instance of the problem, what we can do is we can look at the function plot, which is the orange curve here, and look at where this function has a minimum value. So if you look into this overall function, the minimum value or the location of point where the function has a minimum value is right here, right? So I can take that and I can project that on the w axis, and this point where the w, this point is projected on the w axis, right? This point is the width that will be the optimal value, or w, this point will be the w star value that we are looking for, okay. And then corresponding to that, once I find that, I can use my previous other equations and I can find out the values of L and also the overall tray. So this is approach where I can use a graphical way of solving problem, is now known as a graphical approach. And in couple of classes from now and couple of classes after this, we will be covering some of the graphical approaches, and they are very, very useful to understand a lot of optimization concept. In fact, for two variable problems, and if there are number of constraints and objective function is not that complex, then you can find out a lot of solutions using a graphical approach. And most importantly, there are a lot of good intuition about optimization that you can understand through graphical approach, and that's why we will be focusing on the graphical approach also, okay. So the same problem that we solved using an analytical approach previously could also be solved using a graphical approach, where we can plot things and we can look in the function and say where the function is minima, and then from that we can backtrack the solution that is out there. So before I go into discussing other aspects, what I want to quickly do is I want to quickly go back and talk about how we arrived at this plot, right? And why this is important. And I want to connect this piece with Python coding. We can write a simple Python code which takes this as a function as an input, and with values of w from 2 to 10, we can vary that, and we can use a function plotter to plot this plot, and that can give us a very precise representation or visual aspect of the function that is there that we can use for the solution. So let me quickly switch to retake of the Python notebook examples. So what I have done here is I have essentially created a Python notebook which helps me in plotting the function that I showed in the PowerPoint slide. So let's go through this code, and as you can see, we have some description, and we will be posting this code on the website so that you can play with it. We have essentially created a notebook that allows us to plot the function that we are interested. So we'll start with the running this numpy. So we'll import numpy and we'll run, and then this plot, as you can see, going bottom, essentially will help me plotting this function on a given range, okay. So if I go ahead and I plot this function, you will see a refreshed version, and this plot will look like this, right? So this is essentially the plot of the function 20 plus 200 divided by w plus 10w, and the plot looks like this, where we have essentially increased the values of w and we have plotted the function values out there. Okay. And this is what we were showing, or I was showing, in the PowerPoint slide that we had, where we were essentially focused on creating, this surface plot has this, and we have the surface. So we can use essentially a Python type of plotter to also get this function. But the idea is once you do that, you will be able to use that function plot and you will be able to say that, okay, right here we have the minimum value and this is the w corresponding to which we will have the minimum function value, and that should be the essential solution. So the solution of this problem is like this is where the function has minimum, and this value of w is essentially the w star that we are interested in, and from that we will backtrack and find the solution. So this is the graphical way of solving this problem. But as I said, graphical approach also provides a lot of intuition. So we will carry on graphical based approach to solve for this class of problems. So let's move on to the next slide. Okay. And again, the code that I have in the notebook, I have also given the a snapshot of that right here. So you can write a simple code and that will allow you to plot this function. Something like this could be used to plot this function. Now let's consider a couple of other important aspects and understanding of the optimization problem. Okay, so you have this function, and you know that f star w lies here, right? That's where you have essentially right here is where the function value is minimum. And let's look into imposing some other aspect on this problem and see how that changes the overall solution that we should be considering.